one of the things we do in a geometry class is we think about definitions. And so some things you can kind of define from other things. So a circle's an easy one. A circle is all of the points that have the same distance from the center. Easy. But then you start defining a line. And you got to say, all right, I want it to be a straight line. What does straight mean? It's kind of hard. And there's lots of different ways that mathematicians have used of defining what it is that they mean by straight. So one of the ways that we find very friendly for our brains is if you define straight in terms of distance. So at some point, when you're defining things, you have to stop. Well, this is this kind of a that, and that is a kind of a thus, and thus is a kind of a so. But if you can't just infinitely keep defining things in terms of other things, or you'll never get to start your sentence. And so there are some things that we say, all right, what is a distance? Well, a distance means that I can measure a length between two things that we call points. And that's one of the places where we're going to stop defining things. We're not going to define what a point is. We're going to draw points in the usual way where you put a dot somewhere and say that's a point. But we're not going to have a definition. A point is thus and such. But a distance is a number. It's always positive or zero. And it tells you how far from this point to that point. Now, if I draw some things, I can draw something that looks curvy, and I can draw something that looks pretty straight. And one of the things that you can say about curvy versus straight, that's a very intuitive thing, is we say that the straight line is the shortest path between the endpoints. So if I have an endpoint here and an endpoint here, then if I go by a straight path, then that straight path is, then all of the points on that straight path are on the shortest path. And so my distance from A to B is going to be the same as if I measure the distance to one of these points in between. I'm going to call it X. X is going to be my variable name for all of these different points on the straight line segment. So the distance from A to X plus the distance from X to B is going to be the same as if I go measure the distance from A to B. Now, if I had a curvy path, that should not be true. So let's see, let's use C and D, and I'm going to pick Y as my variable to represent any point on that path. And now, if I measure how far from C to D, I'm not very good at drawing straight lines here. So if I measure from C to D, think of that as being straight, versus if I go by way of point Y, then if I go from C to Y, and then from Y over to D, if Y is not on this straightest path, then the distance from C to Y plus the distance from Y to D should be a little longer than if I measure from C to D. So that's some equations. So this is how we're going to write things. We are going to use these bars. So here's AB. That's going to be the distance from A to B. So I'm using these bars to show the distance between A and B. So I like this way of showing distance because it's a nice compact notation. But also that's a lot like an absolute value, and distance is always positive. So the distance from A to B is the same as the distance from B to A. So making it an absolute value makes sense. And you can think of that as the length of a vector going from A to B. We're not going to be doing vectors very much in this class, but if I was doing vectors, I could use, that's one of the notations I can use for length of a vector. So I'm going to say if x is on the straight path of the line segment from A to B, that means that the distance from A to X plus the distance from X to B is going to be the same as just measuring the distance from A to B. X is on the shortest path. It doesn't take you out of your way at all when you're going from A to B. And so we're going to use that property to define what we mean by a line segment. So my line segment is going to be defined to be a set, and this is a set of points and sometimes we say this is points in the plane. And we're going to use E2 for the plane because it's two-dimensional Euclidean space. So all the points in the plane that have this property. So if there's a point in the plane where if I go from A to X and then from X to B, and it is just as fast as going straight from A to B, we're going to say X is on the shortest path or the straight line segment from A to B. And if Y, notice that if Y is any other point in the plane that's not on that segment, then this distance going first to Y and then over to D, that's always going to be longer than if you just go straight from C to D. And so for any point in the plane, either if I go from C to that point to D, either that's the same length as going straight from C to D, or it's longer to go by way of Y when you're going from C to D. And so we can say that if you have any point in the plane, so I'm going to pick A, I'm going to use A and B and X as a variable again, and these are just any points in the plane. Then either the distance from A to B when I go by way of a third point X. So if I go from A to X and then to B, when compared to going from A to B, no matter what point X is, that is always going to be at least as long as going on the shortest path. It can be longer or it can be equal, but you can't ever get there faster by going to point X first and then to point B, because we're defining this segment to be a shortest path. And so in order for everything to work together, this property has to go into our definition of what it means to be a distance. So we say there's 3 key properties to being a distance that you have to have, or it doesn't make any sense to say it's a distance. So anything that's a distance, we want to have the distance be the same either direction you measure it in. And you can't get from A to B any faster by going to another point first. If it's on the straight line, you can get there just as fast by going from A to X and then from X to B. But you can't get there any faster. And if X is not on the line, then it'll take you slower. It'll take longer to get from A to B. And the third property that we have to have for something to be a distance is we want to say that the distance from any point to itself is 0. And that is an if and only if statement. If the distance from A to X is 0, that means that X is really the same point as A.